Have you noticed that there is like a lot of video on the internet? Um, People watching 500 million hours of video on YouTube every day. And they're watching 100 million hours of video on Facebook every day. Of course, watching this presentation on video through the web. And during the last stay-at-home period brought to you by the COVID-19 global pandemic, video usage has also already gone up with other websites like Twitch, Netflix, other websites which I'll not name for moral and legal reasons. And if you don't believe me, just take a look at these graphs with upward trends. Anyhow, have you ever asked yourselves, how does video on the web actually work? And I hope that by the time you finish watching this talk, if someone comes up to you and says, build me the next YouTube, you'll be able to say with confidence, no, because that's a dumb idea. But if they insist, well, at least you'll know where to start. So video has a long and interesting history, and I'm going to focus on two things. One is the technology, and the other are the politics that led us to this state where we are. And I'm hoping that by having some more context into these two, you'll be able to kind of figure out why things are the way they are and how to use this information for your use cases. So, hi, I'm Opher. I'm a creative developer at Echo. And you might ask, what exactly is a creative developer? So it's about combining my two passions for software and design. I code visuals, animations, sounds, games, and infrastructure to create a new medium of storytelling that's kind of something between a video game and a TV show, and everything using web tech. In short, it's a front-end developer, but it sounds way more hipster and pretentious. So let's start with something simple. Let's start with the image tag. This is the way you present an image on a web page. And if you're a decent human being, you'll include accessibility features like alt and aria tags. And you might ask yourself, what could go wrong here? But the answer is not much. So if the image doesn't exist on the server, you'll get a 404. And if your connection is broken while you're trying to get the image or before that, you may get a non-internet error. And in either case, you either get nothing or you get a broken image. So let's look at the video element and ask ourselves the same thing. So we have a video, we have a source that goes to a video file, and the question is, will it play? The answer is simple. Yes. Unless you wanted to play on different browsers and devices. And you might correctly assume that not all devices and browsers can play the same video files. And why can't they do that? Well, we'll get to that soon. But first, let's try to improve our markup a little bit. So let's add sources to our video element. So the source tag is, as the name specifies, tells the video element which files are available to play. So you can have different types of sources for different types of devices. So here in this example, you have one WebM source for Chrome, Firefox, and Edge, another MP4 source for Safari, iOS, IE, if anyone's still using that, and mobile Safari. And let's ask ourselves the same question. Will this play? And the answer is technically yes. But you also want to provide a video experience in proper quality that doesn't take forever to load. And to understand this, we need to go a little bit into the history of video. I mean, before video on the web, we had broadcast. So what exactly is broadcast? With broadcast, the stream of frames is broadcasted over air or cable, and the broadcaster only has to send one stream. So the stream is always on. It's just there, and you have different clients tuning in to the stream. But Web video works a little different. So with the web, it's impractical to just cast everything, all the video, all the time. It doesn't make sense. Too much bandwidth, too much CPU, too much resources. So you have a server. Everyone requests their video files from the server, their own video files. And you have different clients. So you have different video files for different clients. So, sorry about that. So what does it mean, though, to transfer video digitally? Okay, so what is video? Video is a series of static images or frames displayed one after the other. And let's take a look at one of these frames and trying to think about a naive implementation of a video file to understand how it works. Okay. So, as you know, an image is made out of pixels. To represent 1 pixel, you need 3 values. You need, for the 3 channels, for red, green, and blue, at least 3 values. Now, again, in a naive implementation, you have 8 bits for each value, 3 values, that's a total of 24 bits. And a full HD image, which is 1920 by 1080, turns out to be 9,073,600 pixels. So if you multiply that by 24 bits, you get about 6.22 megabytes for the 1 frame. Now let's assume a constant rate of 23.976 frames per second. This is one of the industry standard frame rates. There are a lot of different standards, but let's take this one. So that means 1 second of video is worth about 149 megabytes. Now, the average runtime of a Tiger King episode is 45 minutes. So that means 1 Tiger King episode in this naive implementation of video would take about 6.7 gigabytes. Hello, all you cool cats and kittens. That's not going to work if you want people download the video over the internet on the web browser. And to understand exactly why, let's talk about video playback. So what exactly is video playback? Video playback is a race between playback and download. The bit rate that I talked about earlier is just that. How many bits does it take to represent 1 second of video? And it has an upper limit, the original bit rate where the video was encoded with. So if the playback is smaller than the download, then you're good. Your video is playing fine. And you might notice or seen this type of bar in the old day of YouTube, where you had the one thing loading and where you're playing. Okay, but what happens if the playback is bigger or is not as big as the download? Then you get buffering because you haven't yet downloaded, or your computer hasn't yet downloaded the cache what you're trying to watch. And this is where codecs come in. So a codec, short for a coder-decoder, is a software algorithm that knows how to compress raw video or audio data into a small file size. And it also knows how to read this compressed data into the actual media, so the reverse process. And this is where things get a little muddy, because you've probably heard about codecs in the past. MP3, for example, that's a universally known codec for audio. And we live in the world of the web, where everything is open and free, but codecs, not so much. So there's this. This is MPEG, not the file, the organization. MPEG stands for the Moving Picture Experts Group. And it's a group of authorities that was formed to set standards for audio and video compression and transmission. Way before the web. I'm talking 1991, where they released the H.261 codec after years of effort by many companies and individuals. And they've released a lot of codecs since, H.262 in 94. One more recent one that you might know is the Advanced Video Codec, or H.264 in 2003. And H.265 more recently in 2013. But the interesting thing here is that in 1997, they started licensing these codecs. So what does it even mean to license codecs? take a look at the H.264 patent holders. The Panasonic Corporation has more than 1,000 patents on this codec alone. So they invested a lot of time and money into it, and they want to get that money back eventually. So that's why you have patent bodies whose job is to collect money for usage of these codecs. So all the Epic ones are licensed using MPEG-LA, which is the company that collects royalties for these. So what does this thing even mean? It means that if you made a DVD player, a Blu-ray player, an HD DSLR, or a set-top box, you'd have to pay royalties. But we're not trying to make DVD players, right? We're trying to build websites. So what does that mean for us? Well, take a look at the video codec licensing terms. Let me make it simple and break it down for you. If Mozilla wanted to ship the H.264 codec with Firefox, just so Firefox users could watch video, it would cost them $5 million in codec licensing. That's crazy, right? So codecs are not just financially expensive, they're also computationally expensive. Think about it. You have to generate frames, video frames on the fly from partial data, again, because it's compressed 24 more times a second. And this is really hard to achieve, especially on small devices with relatively weak processors. If you try to implement a software codec on your smartphone and run it, trust me, you'll burn your fingers while the battery gets empty in no time. And that's why on smartphones, for example, codecs are done in hardware. This is one of the boards on the iPhone 7. It has the Apple A7 chip, which holds the CPU, it holds the GPU, but it also holds dedicated hardware codecs. And specifically the H.264 codec. So remember, I talked about licensing terms and said like if you wanted to make a device, then you'd have to pay royalties. This means that Apple pays for every iPhone they make. That's a lot. That affects the business in a serious way. This means interesting things for us as web developers as well. So if you ever tried to put in a video on a web page and watch it on an iPhone and then watch it on full screen, you get this strange interface. So this doesn't look like the web because it isn't. This is the interface that you're seeing is actually QuickTime interfacing with the hardware codec. So when you're clicking that full screen button on an iPhone, you're not in the browser anymore. You've left that. You're not in Kansas anymore. It's just a black box of QuickTime. And this means that you can't do things like catch JavaScript events because it isn't JavaScript, and you can't overlay DOM elements on top of this video, again, because you're not in the context of the DOM. And you can't do all the things that you're used to from working on the web. Now, who's really responsible for providing codecs? So you might ask yourself, is this the hardware, the OS, the browser? And it's unclear, really. It's a complicated mess of things. Now, don't get me wrong. Those licensed codecs, they're really good pieces of software, and very smart people worked very hard on them. But they don't quite fit the vibe of the web. One fateful year, though, the tables have started to turn. And that year was 2006. You see, 2006 was the year Justin Timberlake was bringing Sexy back. And it was also the same year where I was not. But it was also the year when Google bought YouTube, the largest video content site in the world. So this was a couple of years after Web 2.0 kicked in, and companies started to realize that user-generated content meant business. You have to remember, H.264 was not designed for the internet. It was originally used for digital video services and devices. And the licensing model that I talked about earlier was aligned with that. It wasn't aligned with users using software to browse websites that are hosted by other software on servers. This was not the case at all. So, by the way, 2006, YouTube, a video site. Can you guess, out of the existing codecs at the time, which ones they used? These are three of the codecs that were available at the time, and their actual sizes. I didn't downscale, but everything was tiny back then. Well, I don't know what you guessed, but they used the one with the worst quality of Flash video. How do they do that and not use better codecs like QuickTime or Windows Media Streaming? Because Flash was ubiquitous. It was everywhere. Everyone could run Flash. Every browser had the Flash plugin. But not all browsers, and most of them actually, didn't have the other codecs. So YouTube obviously cared more about letting people watch video. And back then, we didn't have the video elements. That didn't exist. So YouTube, this is an actual embed code from YouTube at the time, used the object element, which is kind of like the ultimate black box. You see, the browser itself couldn't handle any video. You need the external software like QuickTime or Shockwave or Flash. So you had no way of knowing how video works or control it or have any interaction outside what those black boxes allowed you to have. Okay, so now you know about codecs. Let's do a quick recap. In between 91 and 93, we had all these codecs with the licensing. It was up until today, but those were the earlier times. And in 2006, Google buys YouTube. And then interesting things happen. In 2007, the video tag lands in Opera. And actually, Opera were the first one to suggest the spec to the W3C. And in 2010, Google releases VP8, which was the first open codec. So what does an open codec mean? It means that this codec is not only open source, but it is also available for anyone to use. You have to understand that YouTube has a huge incentive to not pay royalties and to not have to push other vendors to include codecs that they don't have or own. Also, in 2011, YouTube goes full HTML5. The largest video site in the world giving a stamp of approval to release new HTML5 technology by switching over to completely. That's a huge thing. In 2013, they released VP9. By the way, VP stands for Video Processing Codec. And this codec is very optimized for web playing. So there's like segmented playing where you can have to download just part of the file, better quality for better compression, etc. 2014 is also interesting. Cisco, the people from the routers, they released the Open H.264 for all browsers. So this is a variant of H.264. And they also pay royalties for all browsers to use. So they were kind of like okay, we're going to be the good guys, and we're going to take this on us so everyone can pay this very ubiquitous codec on everyone's machines. And then in 2018, AO Media, which is the Alliance for Open Media, it's like a body that includes all the big companies, Google, Apple, Facebook, whatever. And I'm not sure Facebook is there actually, but they released AV1, which is another codec for the web. Okay, codecs, enough about those. Let's talk about containers. Not these types of containers, these types of containers. That's the last thing you need to know to understand this puzzle. So what are containers? Containers are a binary data structure. They hold video streams and metadata like codec, bitrate, resolution, subtitles, audio streams. You've probably seen them before, like Move, MP4, WebM, or MKV. And the idea behind containers is that not only they hold all of this information, then the binary structure of the data is built in a way that's specific for use cases. So you have like Move, which is specific, aimed for editing. So you can do fast seeking between places in the video. MP4 and WebM are containers that are more fit for playback. So you get compressed streams, and you can play them as you download, but they're worse for just seeking between different places in a file. So let's go back to our video element. And this time we have our different sources, and the different sources have different codecs in them. And the video element is smart. So essentially you give the browser the different options, and they automatically choose which format they can play. So you don't have to say, if you're Firefox, play this. If you're Chrome or iOS or whatever, play this. And let's get back to our question and ask, will this play? And you know where I'm going with this. Yes. If your users are at the office or home where they have a really good internet connection, nobody else is using it, you have no problem with your server exploding. You see, video files are big. They're not like an image that takes a second to download. It's a long transaction which takes up all the sockets on your server. And what if many users try to view the same video file at the same time? You don't want your video files hosted on the same server that hosts your HTML. Okay, so maybe not. Let's not host our videos on the website. Let's use a CDN instead. So back to our video elements. This time we're pointing our files to a CDN. CDN, by the way, stands for Content Delivery Network. I hope you know this. If not, really short, it means that there's like a network of servers in different physical locations around the world, and when you request a file, instead of going to this remote place where it basically takes time for the signal to pass through, the server is closer to you, so it's faster. This shortens the time it takes for the video to load, and it also removes that load from the server, again, because you want to separate the two. And will this play? Yes. But you also probably care about people watching the video on their mobile phone or on train or anywhere that's an underpowered device on a shitty bandwidth. And to understand this, we need to talk about progressive download. So up until now, that's kind of what we've done. What is progressive download? So like an image, when you put an image tag, your browser downloads the image to cache so it can display it. And it's the same with video progressive download. So your browser downloads this video files to cache, and then it can play the parts of the video that were already downloaded. But this means a couple of things. It means that you can only play what you have in cache. You can't play what you haven't downloaded. So that means you can't seek forward because you can't jump into different places in the file because you haven't downloaded those parts yet. And this also poses a problem on mobile where space, time, and bandwidth are very limited. You can't download giant files into people's machines that then have no memory, or that their bandwidth sucks, or it also takes a lot of time. That's why much of the videos today go through video stream. So what exactly is video streaming? So instead of just downloading one huge file and having it on cache on the client, video stream works by the client communicating with the server, and the server just sends just small chunks of video that are relevant to what exactly is the client wants to play at this time. So the client doesn't have a huge cache on its device at any given point, but just really small cache of just barely the amount of video that it's been playing. So this means that if you're at home and the members of your family, someone's watching video on their tablet, someone's playing a game, someone's watching Netflix, someone's watching on their computer, your bandwidth constantly changes depending on what the people on the same net are doing. If you're on the bus and you're watching a video on your mobile phone, and the bus and your phone keeps connecting to different nodes of the cellular network, your bandwidth could also change. If you're watching a video and you're entering an elevator and suddenly the signal drops, I don't know why you're watching a video in an elevator. Don't do that. That's rude. But you might be doing that, and then your signal changes. So in all these cases, the amount of bandwidth that you have keeps shifting and changing. And that means that if you started downloading video at a very high quality, and suddenly your bandwidth shrinks down, again, you won't be able to fetch the same amount of data that you could before, and it'll get into buffering. And that's why we have something called adaptive bitrate. So adaptive bitrate means that the bitrate changes depending on your network condition. So in this example, you start out with this low setting. So you get a video that's either smaller resolution, a smaller bitrate, again, a smaller file size, and your bandwidth is measured all the time. And if you have more bandwidth, then the next chunk that the service sends you is of higher quality. And this can go up and down and up and down. You've seen this on YouTube, you've seen this on Netflix. This is kind of like the industry standard of doing things. And speaking of standards, every company doesn't implement this on their own. At least most don't. That's why you have streaming standards. So two interesting ones are MPEG-, which stands for the Motion Picture Experts Group Dynamic Adaptive Streaming over HTTP. That's a mouthful. Or HLS, HTTP live streaming. That's an Apple format that's also quite popular that they implemented in 2009, I think. And the idea is this: you have clients that implement this protocol, you have servers that implement this protocol, and all the information about like how to do this adaptive bitrate, where to get the data, where to get the files, how to tell the client which files to get, everything is specified in these protocols, so you don't have to deal with actually implementing all this low-level stuff yourself. Although, if you wanted to implement this low-level stuff yourself, there's the Media Source Extensions API, which is kind of an API for the video element in the browser, which allows you to build dynamic streams in JavaScript. That's part of what I do at work, which is pretty cool. You actually handle a lot of this stuff and more on your own JavaScript, actually build the binary streams in the browser, then feed them to the video element. Most people would never need to touch this, but it's really cool to know that browsers, at least most of them, not some of them, offer you this kind of flexibility. Let's go back to our video elements. And this time we have sources that point to weird things like an MPD file or M3U8 file. These are actually manifest files of these streaming standards that tell them the browser like where to fetch the files and where to get them, where the URLs are, all that good stuff. And you asked yourself again, will this play? And the answer is finally yes. Until it doesn't, because something always goes wrong with video. Errors that you might get, for example, on your video element, stalled, which is when you started downloading a video and the browser stopped getting data because maybe the internet stopped working at your ISP or your router broke down, but your computer is still connected to the network. Or the server stops staying for some reason. Suspend, it's when your browser isn't getting data intentionally, so it knows why. For example, if you're downloading a lot of resources, and some of them are video, but others are, I don't know, JavaScript, CSS, images, and your browser decides to prioritize things before the video. Emptied is if, for some reason, the binary stream that goes into the video stopped. Abort is when the media data was aborted. So if the stream stopped midway or something like that. And there are errors that the browser doesn't even know what went wrong. And I might be scaring you with all this super low-level stuff into video, and you might be asking yourself, do I really have to handle all of this stuff? Probably not. But it's good to kind of understand what's all behind all this magical tags that we're using in our everyday lives and understand the abstractions so that when the abstractions break down, you have a small idea of where to start looking. And for most use cases, you wouldn't have to deal with all this stuff. And let me give you some examples of use cases. If you want to do something like a video hero image, what I call ornamental purposes, then it's completely fine to just use the video tags, point the video files, different video files at the CDN. Just make sure that it's muted so that you have the mute tags if you wanted to properly play in iOS. So iOS plays nicely. If your business is about video content, so you're serving content to your users, then there are platforms that do all the heavy lifting of encoding for the different platforms, hosting, and playing on different clients. They do it for you. You can use Vimeo, you can use JW Player, or you can even use YouTube. You don't have to worry about the low-level video stuff. If you're all about video manipulation, check this out. It's like a camera, it's like a Snapchat filter in real time. I don't think I've shared audio, so I don't think if you're hearing what I'm hearing. So if you don't, just imagine the theme song from not the song, like that famous song from House of Paper. So video has really cool APIs. You can work with they work with Canvas, with shaders, a lot of other cool visual stuff. And if you want to take video a few steps forward, this is something I did at work at Echo. It's an interactive video game where you play against the Detroit Pistons. So you have this video, and as a user, you're like kind of swiping and trying to matching certain gestures on the screen, and these control whether you succeed or fail in shooting, blocking, or doing all the things that one would do in basketball. But the cool thing here is the video never stops, so it's like a completely seamless experience where it's just one smooth video experience that makes you really immersed in this basketball game. So to sum it up, web video must adapt the browser, the hardware, screen resolution, network conditions, and even more. But remember, it's much more complicated than just putting an image out there, but it's also so much more fun. So thank you. If you want to learn more about video and other stuff that I'm doing, not necessarily work, but about web, the best way to follow me would be on Twitter if you're on that. I usually post interesting web stuff over there. And I'm also in charge of the engineering blog on Echo Engineering. So it's all good content. We're not just trying to push Echo. You're welcome. Thank you so much for having me.